Limits part 2. Now we are looking at other type of limits which we have to deal with. So when you plug in t equals -2 to this expression, your limit as t approaches -2 looks like this. So when you replace t with -2, you get -2 plus 2 in numerator, and you get -2, which is 4 squared, and minus 4 in denominator. So what we see here, we have a limit as t approaches -2 of 0 over 0. What to do next? Usually it occurs when you have a rational expression and you need to work on this rational expression by reducing common factors. So let's factor everything what is not in squared minus b squared formula, difference of two squares, and here we have t plus. As you can see, I can cancel t plus 2 in numerator and t plus 2 in denominator. Don't forget that you still have 1 left in numerator after you reduce by dividing by t plus 2. So you have 1 over t minus. So we reduced the rational expression. What does it mean for this function? F of t equals t plus 2 divided by the quantity t squared minus 1. It means that the function still will not have value at t equals -2, which we cancel, but its graph will have almost the same shape as the graph of function 1 over the quantity t minus 2. Use this expression for the limit, and that will be limit as t approaches -2 or 1 over t minus 2. So what you have here, you plug in 1 over -2 minus 2 and calculate the value, which is -1/4. So if we, so here's for you to see what's going on. I graph the function f of x equals x plus 2 over the quantity x squared minus 2. And you can see clearly that vertical line x equals 2, which is here, is a vertical asymptote. That's correct. But at x equals -2, the one we already reduced the fraction, we're supposed to have a hole like this. And you see it said undefined, but it does not show this hole on the graph like it's supposed to be like so. So please pay attention when you graph a function on a calculator. It's not always what you see. Sometimes you have to apply the knowledge of the and properties of the function. This example, we learned that if we're dealing with a rational expression and we want to find the limit at value of independent variable that turns the denominator in 0 at the same time turns numerator in 0, that it's a root for both, and we can reduce that. Now, what happens here if we plug in 1? We will have square root of 1 plus 3, which is square root of 4, is 2 minus 2, 0, and 1 minus 1, 0. So again, we have a situation 1 minus 1. So we need to work on this rational expression. So we have y plus 3 subtract 2 over y minus. And again, since y equals 1 turns both into 0, that means that there's some way we can reach. So we will multiply numerator and denominator by the conjugate, square root of y plus 3 plus 2. And the same we do here. So we multiply denominator. As you remember, you cannot just multiply numerator and expect that your rational expression will be the same. You have to multiply. Now here we have a minus b times a plus b formula, which is a squared minus b squared. So what happens if you square square root? You get y plus 3. And what happens if you square 2? You get 4. So that's your a squared, and this is your b squared. So here we keep it like so. Y minus 1, we do not multiply, we just keep it. And as you can see, we have y plus 3 minus 4, which is y minus 1. And this y minus 1 will be easily cancelled with y minus 1 at the bottom of this expression or in denominator, let's say. And here we have plus 2 close bracket. So once we reduce this, we again have 1, because it could be written like so, times 1. So 1 over square root of y plus 3 plus 2. So we continue from this limit, and we have limit as y approaches 1 over square root of y plus 3 plus 2. And now we can plug in 1, calculate the value 1 over square root of 1 plus 3 plus 2. This technique we call multiplying by conjugate based on the formula a minus b quantity times a plus b quantity will be equal to a squared minus b squared. So what is 1 plus 3? 4. Square root of 4 is 2 here. 2 and 2 plus 2 is 4. So you get 1, 4. Next step. Suppose limit as x approaches -1, function f of x approaches -3. And suppose that limit p of x as x approaches -1, 4. Find the following limits. Here we have to use the properties of limit. And the properties of limit tell you if such limits exist, we can do it straight by replacing. So we're going from limit over different limit, and then we plug in the value of each limit here. -3 for limit as x approaches -1 f of x is -3 minus 5, and this limit will be 4. So that's how you use the proof. So what will be here? We have -6 minus 20, -26. Similar situation here. What if the product again, if limits exist as x approaches -1, we will use this limit. So x will be -1, x approaches -1, -1. Limit of x is -3, and limit p of x is +4. So -1 times -3, +3 times 4 will. All these examples help you to understand limits better.